Hey everyone, and welcome to this explainer. Today, we are tackling a notoriously tricky engineering problem, solving CAPTCHAs inside Elixir Broadway pipelines. If you've ever tried building an automated flow that has to navigate past a CAPTCHA-protected login, well, you already know the struggle. Moving from a quick local script that works perfectly on your laptop to a robust, unattended production pipeline is basically a massive headache. But don't worry, today we're going to break down exactly how to build a production-ready playbook to make those pipelines completely rock solid.
Okay, let's dive into this. Why is it that these CAPTCHA integrations so often fail the literal minute after deployment? We've all been there, right? It looks deceptively simple in a Jupyter notebook or a local Elixir script. You fire it up, and boom, you get a green checkmark in 5 minutes. But the moment you deploy it to run unattended, like in CI, a cron job, or sitting behind an internal queue, it just instantly breaks. It's super frustrating, but there's a very logical reason for it, and it really comes down to the chaotic transition from testing into real-world operations.
To get you to that bulletproof integration, here's our roadmap for today's explainer. We'll look at why production pipelines fail, walk through the recommended workflow, hit the operational checklist, troubleshoot some common failures, and finally, dive into scaling and monitoring metrics. We're building a highly pragmatic, rule-by-rule playbook today.
All right, kicking things off with Section 1, Why Production Pipelines Fail. You can think of this as the trough of sorrow in automation. It's that exact moment where the confidence of a successful local test slams into the painful reality of unattended production execution.
Now, what's really interesting about this comparison is the massive gap between a demo and reality. A demo system gives you this false sense of security, right? Because it works in 5 minutes on a totally happy path manual run. But production is pure operational chaos. We are talking unattended CI/CD runs, sudden network hiccups, unexpected retries, and super tight deploy windows. Your Elixir Broadway pipeline literally has to survive all of these environmental hurdles without anyone there to hold its hand.
But wait, before we start talking architecture, we absolutely must establish a clear operational boundary. We call this the safe scope. You should only be running these CAPTCHA workflows in environments you actually own, or that you operate for an authorized client, or where you have a clear, permitted data collection agreement. This explainer is strictly about stabilizing predictable, authorized setups. It's a fundamental ethical and architectural baseline for everything we're about to build.
With that baseline clearly set, let's move right into the solution phase. Section 2, the recommended workflow. This is where we finally ditch those fragile, ad hoc scripts and replace them with a structured, modular submit, pull, apply workflow that Broadway can handle efficiently. Think of this as a very clear mental map of the architecture, moving step by step from challenge interception all the way to final application. Step 1, capture exactly what the solver needs from the live page, like the site key and the URL. Nothing more so you don't create false debugging paths later. Step 2, submit the task via the API, making sure you treat any non-200 status as a hard error. Step 3, pull for the result, using highly controlled timing. And Step 4, apply the token. Actually, let's zoom in on the timing of that polling step, because it's a huge trap for a lot of teams.
So, the crucial point is exactly how you manage that polling timing. The magic number here is 120. Here's the rhythm. You want to wait 15 seconds before the very first poll, then poll every 5 seconds after that. But, and this is a big but, you must implement a hard cap of 120 seconds per task. Overpolling just adds a ton of noise and load to your API. Underpolling slows down your entire Broadway workflow, and waiting indefinitely, well, that's pretty much a guaranteed way to crash your worker queues entirely.
Now, skipping over to Step 4 from our workflow, we hit a critical definition: session consistency. Simply put, this means applying the solve token inside the exact same browser context, HTTP client, and cookie jar that initially triggered the challenge. Look, if you get a valid token from an API, but you try to inject it using a completely different session, it's going to fail. Every time. In fact, a mismatched session is quite literally the single most common cause of post-solve token rejection in production.
Okay, so that's the core workflow structure. Next up, Section 3, the operational checklist. These are the strict operational rules that separate a genuinely robust Elixir Broadway pipeline from a script that breaks the second you look away. Let's ground this theory in another hard number: 3. This is your maximum retry budget. I mean it, infinite retry loops are incredibly dangerous because they hide the real defects in your code and just rapidly burn through your API balance. You have to cap retries at exactly 3 attempts, utilize exponential backoff for those attempts, and make absolutely sure you're logging every single terminal failure so you know exactly when and why things stopped. And this brilliantly illustrates a really fundamental misunderstanding a lot of engineering teams have. There is a massive difference between solve success and workflow success. Solve success just means your request inputs were correct and the solver matched the challenge, which is great, but workflow success means the downstream verification actually accepted your token in that same session. A solve task gives you total false confidence if the overall workflow fails anyway. You absolutely must track these as two entirely separate things.
Of course, even with the absolute best pipelines, things are eventually going to go sideways in production. So welcome to Section 4, Troubleshooting Common Failures. Let's directly address the inevitable issues and those dreaded late-night Friday pager alerts you're bound to face.
Let's walk through this quick debugging grid. Honestly, these symptoms cover about 90% of the support issues teams run into. If you see error_wrong user key, it almost always means a key got copied with some stray whitespace, so the fix is just to roll your CI secret. Error 0 balance means you've hit the per task minimum and you just need to top up before retrying. And like we talked about earlier, if your token is rejected after a successful solve, you've definitely failed to maintain that browser context. The good news? Most of these are quick one-line fixes. The bad news? You can only fix them quickly if you've properly logged the full API response in your pipeline to begin with.
Now, once your pipeline is humming along smoothly, your next job is keeping it healthy over the long haul. That brings us to our final operational phase, Section 5, Scaling and Monitoring Metrics. This is all about how you manage your integrations effectively at scale without just lighting your budget on fire.
Let's move on and see how this builds a complete picture of your pipeline's health. We have to anchor our monitoring strategy in strict KPI threshold limits. So, for example, your target for first solve latency at the P50 level should be under 25 seconds for token CAPTCHAs. If it's creeping higher than that, you're probably stuck waiting on retries. Meanwhile, your end-to-end acceptance needs to be sitting at 95% or higher. Look, if you can't measure these exact KPIs, you simply cannot defend the reliability of your system. You need to wire these metrics into your existing dashboards today so you can spot regressions way before your users ever notice.
Now here's a massive scaling advantage of structuring your Broadway pipeline this way: API consistency. The reality is the CAPTCHA family on a target page can and probably will change over time. But because you've modularized that submit and pull loop, your architecture just absorbs the change effortlessly. You literally just swap the task type parameter, keep the exact same submit, pull, apply loop, and ship it. No total pipeline rebuild required at all, which is going to keep your scaling costs wonderfully predictable.
We're going to wrap up today's explainer with this final provocative thought. Reliable CAPTCHA handling is primarily an operational problem, not a coding problem. If your workflow only succeeds during a local test, it isn't production ready, period. You have to focus on observability, maintaining session consistency, and enforcing those tight retry budgets. Apply this playbook, and you'll completely eliminate those late-night alerts. So I'll leave you with this. Looking at your current automation architecture right now, is it truly production ready? Or is it just a successful local script waiting to break? Thanks so much for joining me on this explainer, and I really hope this helps you build bulletproof Elixir pipelines.